Welcome friends, this is Atanu Chaudhary of SureSolve. Continuing from the first part of the video, in the second part, we'll solve the question 6 to question 10 of SSC CGL Algebra Solution Set 6 from SureSolve.com. Let's solve the first problem. Question 6 is, if a and b are positive integers such that a square minus b square equal to 19, then a is option A 8, option B 0, option C 9 and option D 10. We have a two variable equation and we have to find the value of a single variable. The problem is not straightforward, but we find a pattern. We break up a square minus b square into its two factors, a plus b into a minus b. Let's write the two factors. A plus b multiplied by a minus b equal to 19. This is the first breakthrough. Here we identify 19 as a prime, and by the property of a prime, it has no factors other than 1 and itself. So a minus b must be equal to 1 and a plus b must be equal to 19. A minus b equal to 1, a plus b equal to 19. Add them up, you'll get 2a equal to 20. This means a equal to 10. Answer option D 10. Can be easily solved in mind only if you can break up a square minus b square into its two factors, a plus b and a minus b, and then use the property of the prime 19. Let's solve the next problem. Question 7 is, if x square plus bx plus c equal to a multiplied by x minus b whole square, then the relation between a, b and c can be expressed as option A b square equal to ac, option B abc equal to 1, option C 2b equal to a plus c, and option D b square equal to 4ac. We have to compare the coefficients of like terms on both sides of the equation. So we expand the right hand side of the equation and get x square plus bx plus c equal to x square minus 2apx plus ap square. Coefficients of the first term is same, which is a. Equating the coefficients of the second term, we get b equal to minus 2ap. And comparing the third terms, we get c equal to ap square. We have to eliminate p. From the first equation, we get p equal to minus b by 2a. Substituting the value of p in the second equation, we get c equal to a into minus b by 2a whole square equal to ab square by 4a square. A cancels out. Finally, this results in b square equal to 4ac. So option D is the answer. B square equal to 4ac. Answer option D. The problem can easily be solved in mind. Let's solve the next question. This is a difficult surd problem. The question 8 is, if x equal to 5 minus root 21, then the value of root x divided by root 32 minus 2x minus root 21 is option A 1 by root 2 multiplied by root 3 minus root 7, option B 1 by root 2 multiplied by root 7 minus root 3, option C 1 by root 2 multiplied by root 7 plus root 3, and option D 1 by root 2 multiplied by 3 plus root 7. As the value of x is a surd expression, root x is a double square root surd. There is a standard method of simplifying such a double square root surd. Before putting the value of x in the target expression, by the general principle of simplification, we'll get on with simplifying the target expression as far as possible. This is always to be done. To simplify the target, we have to simplify the denominator. And in the denominator, we have to simplify the first square root. The denominator is root over 32 minus 2x minus root over 21. This is equal to root over 32 minus, this time you substitute the value of x to get minus 10 plus 2 root 21 minus root over 21. 32 minus 10 is 22. So you get root over 22 plus 2 root 21 minus root 21. This expression 22 plus 2 root 21 we must express as a square of two-term surd expression, where the surd term will be the middle term. As coefficient of 2 already exists, root 21 will form the product of the two terms. So the two terms must be 1 and root 21. And sum of the squares of the two terms is 22. So this is equal to root 21 plus 1 whole square under square root minus root 21 equal to root 21 plus 1 minus root 21. Root 21 gets cancelled out. The denominator becomes just simple 1. So the target expression is simplified to just root x equal to root over 5 minus root 21. This was the first double square root surd simplification, and now we have to simplify this double square root surd again. The first one was easy because the coefficient of 2 existed with the surd term, but here there is no coefficient of 2 with the surd term root 21. This is the second method of double square root surd simplification. Here we'll multiply and divide the surd expression 5 minus root 21 by 2 to get 1 by root 2 root over 10 minus 2 root 21. We have forcibly introduced the coefficient of 2 with the surd term root 21. This time we'll break up the root 21 into its two factors, root 7 and root 3. The sum of the square of these two terms will be 10. So this will be equal to 1 by root 2 root over root 7 minus root 3 whole square. The middle term will be minus 2 root 21 and 7 plus 3 is 10 equal to 1 by root 2 root 7 minus root 3. That is the value of the target expression. Answer is option B. If you follow the proper methods using the two techniques of double square root surd simplification, then you can solve this problem quickly enough. Let's solve the next problem. Question 9 is, if a to the power 1 by 3 equal to 11, then a square minus 331a is option A 1331331, option B 1334331, option C 1331000, and option D 1330030. For getting the value of a, you have to raise 11 to its cube, which itself is quite large, and then to evaluate a square, you have to raise 11 to the power of 6, which is very large. Would you follow this path? Rather, following the general principle of algebraic expression simplification, we'll simplify the target expression first. We'll take a common to get the target expression as a into a minus 331. Now we have to calculate the value of a as a equal to 11 cube equal to 1331. We mentally calculate the cube of 11 by first calculating 120 into 11 as 1320 and then adding 11 to 1320 with a result of 1331. Now we substitute the value of a to get equal to 1000a. A we know as 1331, so 1000a is option C. Answer option C. The problem can be easily solved in mind. Let's solve the last problem. The question 10 is, if a equal to xy by x plus y, b equal to xz by x plus z, and c equal to yz by y plus z, where a, b and c are all non-zero numbers, then the value of x is option A 2abc by ab plus ac minus bc, option B 2abc by ab plus bc minus ac, option C 2abc by ab plus bc plus ac, and option D 2abc by ac plus bc minus ac. This is not an easy problem. Here 6 variables are involved, a, b, c and x, y and z. We have to find the value of x by eliminating y and z. How is it possible? Which way we have to proceed? When we examine the value of A, we discovered the breakthrough pattern. We'll invert A to 1 by A equal to x plus y by xy equal to 1 by x plus 1 by y. At one stroke, we'll get rid of xy, which was causing all the problems, along with the denominator of x plus y. It's now sum of individual terms 1 by x and 1 by y. The simple action of inversion has given us the breakthrough. We call this as the inversion technique. Similarly, 1 by b equal to 1 by z plus 1 by x and 1 by c equal to 1 by y plus 1 by z. The problem is fully under control now. We have to find the value of x. So we have to eliminate y and z. We'll sum up these two equations first. To get 2 by x plus 1 by y plus 1 by z equal to 1 by a plus 1 by b equal to a plus b by ab. In this equation, we will substitute the value of 1 by y plus 1 by z from the third equation to get 2 by x equal to a plus b by ab minus 1 by c equal to ac plus bc minus ab divided by abc. Invert, take 2 on the other side, you will get x equal to 2abc by ac plus bc minus ab. Answer is option D. This is a problem to be solved quickly by applying a special technique. This has been an interesting set of 5 questions to solve. If you want to read the detailed solutions, refer to the article on SureSolve.com, the link we have given in the description of this video. Thanks for watching.